Alright, so in this video we are going to be simplifying a sum or difference of two univariate polynomials. So univariate, what that means is one variable. So there's only one variable in these. So you can see there's y, there's y, there's y. We have y squared, but it's still y. In this equation, or this expression, sorry, not equation, we have t's instead of y's. But there's only one variable. I don't see anything that looks like this, where I have two variables next to each other. That would be called multivariate, but this one's univariate, meaning one variable. All right, so in order to do that, let's kind of review really quick just what like terms mean. So all the terms in an expression represent numbers. Remember, we were learning that on the last video. So some are constant and some are being multiplied. A constant number is something like 7 or 200. You know, it's not being multiplied by anything, I just know what that number is. If it's being multiplied by something, now it has a variable next to it. So this means 7 times x, 200 times y. Okay, so that's all that means. Numbers that are alike have the same operation, meaning they're either being multiplied by the same variable or they're not being multiplied at all. They're just, like 7 or 200. Constants are like terms. So those are numbers that are alike. If I have 7x and 200y, like I had just a second ago, these are not like terms. They're being multiplied by different numbers. So the same operation, but different numbers. But if I was multiplying by the same thing, now they're like terms again, because they are under the same operation, being multiplied by the same number. So we just want to make sure before we combine that we're looking at, which ones are alike. So if we look at these little symbols here, how can we group these? They're all fruit, so I could group them in a big grouping of fruit, but I could group them by type of fruit, right? I could definitely divide them up and say, well, I have 3 apples, I have 2 grapes here, and I have this watermelon on the end. So I can definitely group them by type of fruit. That's possible. So this is the same for variables. Constants are the numbers that are not being multiplied, such as 3 or 57, so 2 more examples there. Variables they have to be the same letter, different letters represent different numbers, just like we talked about a second ago. X and Y, those are not the same. Remember, a variable, when I say 7x, like I had up above, this is just a placeholder. I don't know what x is. 7's being multiplied by something, but I don't know what that something is. The x is holding the place of the something for me. Okay, so that's why different letters represent, when we use them as variables, they represent different numbers. Also, the variables have to have the same exponent, because exponents represent repeated multiplication. So if I had something like 7x and 7x squared, well, these are not like terms anymore, because this means 7 times x, and this means 7 times x times x. That's what the x squared means. That means I'm repeating that multiplication. So it's not the same operation anymore. Now I have 2 multiplication pieces there instead of just the 1. All right, so now we can replace the items above with variables and combine like terms. So instead, what I'm just going to do is look at this and go, okay, I'm going to go for A for apple, G for grape, A for apple, G for grape, and W for watermelon. So I just did the first letter of each of the types of fruit. You can use whatever letters you would like. You can also use symbols like an @ symbol or a question mark. I've done that plenty of times in class just to prove the point. They're just placeholders. You can use any symbol you want. All right, so now we're just going to combine. Well, how many A's or apples do I have? I have 3 apples. So 3 times A, or 3 apples. How many grapes? 2. And I just put that in front. So this is called the coefficient. It's telling me how many of that variable I have. And for W, I just have 1 of those. So this is kind of the idea, a simplified idea of adding like terms. So that's what we're going to do down here for simplifying sum or difference of 2 univariate polynomials. So when I have the groupings, I do really want to pay attention to that symbol in the middle. If it's an addition sign, it's not actually going to change anything. We can just start adding like terms. So I can start identifying, this one has a y squared, and this one has a y squared. So they are like terms, and I can just add the numbers, the coefficients in front. I have 6 y squareds over here. I have 4 more over here. So 6 plus 4 is 10. And I just put the y squared on kind of tack it on there. Okay, because that's how many y squareds I have. And then I only have this y without a square on it. So I don't have anything to add to that. But I do have a 7 and a negative 2. So I can add 7 plus negative 2. So sometimes that kind of throws students off there a little bit. Really, it means 7 minus 2. Whenever I have plus minus, it means minus. Okay, so I have plus 5. So there we go. I've simplified that expression. So now down here, again, we want to pay attention to that sign, because that is going to change some things. So I give you a little hint over here. The subtraction sign changes all the signs of the terms in the second parentheses. It is distributed to each term. So literally I need to distribute this negative sign to every term. Remember, everyone is separated by that either addition or subtraction sign. And what it's going to do is it's going to flip all the signs. So this is going to go plus, this is going to go negative, plus, and this is going to turn into a negative sign. So all the signs flip, and I turn that into a plus sign because I'm giving it away. Okay, that's kind of a simplified explanation of what I'm doing there, but I'm distributing it, okay? So now I can go to my squareds again. So I have 2t squared at the beginning, and I have negative 3t squared. So this is 2 minus 3. So this is going to be negative 1t squared. I don't need to put the negative 1. I do need the negative, but I can just say negative t squared. I don't actually have to put the 1 there because it's assumed that it's there. And then again, I only have that one middle term. There is no other, just t without the square. So I can just go plus 4t. And then I have 6 minus 1. So 6 minus 1 is 5. All right, so we have simplified both of those terms. So that is how we simplify either a sum or difference. Again, pay attention to whether or not it's a plus sign or a minus sign, because that does change things a little bit. But go ahead and jump on Alex and give it a try.